0.95 per unit to 1.055. The voltage level at which your generator is working, it may vary between 0.95 per unit to 1.05 per unit, 95% to 105%. So 5% variation is allowed. So in case of the frequency stability, we allow only 1% variation. So our standard frequency is 50 Hz. So it can be allowed from 49.5 to 50.5 Hz. So this is the variation. Means this is the tolerable limits that your system can work at 49.5 or 50.5. So third, so for this we need, if in order to make the stable, we do some types of the compensation. Okay. For this purpose, we use the Gardner action. When the speed is reducing, so our Gardner is acting, so it leads to increase the speed or decrease in the speed. So we require the Gardner action in order to control the frequency stability. So angular stability. So angular stability is linked with the angle of the rotor with respect to the your synchronously revolving field. So we have different types of the angular stability. So in this we have the steady state stability. Steady state stability. Transient stability. Dynamic stability. So we have the three types of the stability. Steady state stability means we are gradually increasing the load or your input to the machine is gradually increasing. So this leads to increase in this delta. And if you plot the curve between your power and the delta, which is known as a power delta curve, so our variation will be like this. From this equation, our variation will be like this. And we have the maximum power which can be transferred from a generator is when delta is equal to 90 degree. So when delta sin delta 90, so we have what? So this is equal to maximum value of the power is equal to P max. This is known as the PE, P max sin of delta. So maximum value of the power can be transferred. So if there is a gradual change in the your angle delta, and when delta is gradually increased, and ultimately it is less than 90 degree, then we can say our machine is a stable one, and this type of stability is known as the steady state stability. So next is the transient stability. So in case of the transient stability means we have the disturbance. So disturbance means there is a fault on the line. So we have lot of disturbance. Means there is short circuit occurs. So lot of disturbance on the machine. We switch off or switch on in line. Okay? So due to that we have the transients, lot of disturbance. So in that case there is a lot of fluctuations, vibrations in the rotor. And if means you have increased a load or some type of disturbance has occurred, then you may have your delta will change, and ultimately your delta may adjust at some new value. Your delta will adjust at the new value, and at new value of delta this is the value when the delta, your machine is running under the initial condition. Let us suppose your delta was delta 0. And when some disturbance has occurred, you have a new value of delta, which is equal to, this is equal to delta. And if your machine settled down, means after the variations, your delta settled down at this new value of delta, and again your rotor starts rotating at the synchronous speed with the angle delta 1, then we can say our system is a stable. And if your delta is continuously increasing, if the delta is continuously increasing and it not means continuously go on increasing, so that is known as an unstable system. So dynamic stability. So in case of the dynamic stability means small disturbance we have. The small disturbance in the your rotor due to which the rotor is vibrating. So that type of stability is known as dynamic. So the two types of the stability we are going to study in this chapter, which are the your steady state stability and the transient stability. The two types of the synchronous machines. One is known as the generator, synchronous generator. Another one is synchronous motor. So in case of the generator, stationary reactors. This angle is theta and this angle is delta. Means your delta is ahead of your synchronous revolving field. Rotor is ahead of the synchronous rotating field in case of the generator. And in case of the motor, we have the this angle is so here means our this synchronously revolving axis is rotating at the synchronous speed. So this is the angle which is covered by this theta, in this case of generator. Theta is equal to omega s p plus delta. it is continuously revolving with respect to the stationary axis. So this angle is continuously increasing. So how much distance? This is the angular distance. So angular distance means the linear distance is equal to velocity into time. Similarly, this distance is equal to omega s into t plus this angle delta. That will give the theta. So here this is equal to your theta is equal to so this angle minus this delta. Okay? So this is equal to omega s t minus delta. In case of motor, this is generator. It is the case of generator, and it is the case of motor. Okay? So from this we have the d theta by dt is equal to omega s plus d delta by dt and d square theta by dt square is equal to d2 delta by dt square. Similarly here again, d2 theta by d delta square is equal to this. So this d theta by dt is giving the angular velocity. It is giving you the angular velocity. This is equal to omega r, and d square theta by dt square is equal to this is equal to angular acceleration. It is the angular acceleration. So we have the, in case of the generator, we give the mechanical input, we are getting the mechanical torque which leads to electrical torque, and your angular velocity omega r, and we are getting the electrical torque. And in case of the generator, we supply the electrical power, and from this we are getting the mechanical power. So we have your electrical torque, mechanical torque, and angular. So here we are giving some mechanical power. We are giving the mechanical power, and we are getting the electrical power. And when your rotor starts rotating at the synchronous speed, the rate of change of delta becomes 0. When the rate of change of delta becomes 0, under that case your mechanical power is equal to the electrical power. Right? But if we neglect your friction and windage losses in the machine, then how much mechanical power we are giving, that will be equal to the electrical power. So this your PM is equal to PE. But if it is not same, is the mechanical power is greater than the electrical power. So under that case, the PM minus PE will have some power that is known as a accelerating power. This is known as a accelerating power. Similarly, in case of the motor, we are giving the electrical power. So electrical power PE minus PM is giving the accelerating power PA.